Okay, let's look at the first one in section 10.6 on power series. We're going to use the ratio test to determine the radius of convergence of this power series right here. Okay, so clearly we're centered about x equals 0, and we know it converges for x equal to 0. Obviously, this is just 0 in that case. So let's look for x not equal to 0, for which we could use the ratio test. Remember the ratio test, if you recall, requires us to have, right, um, division here. And so we have to have the terms to be greater than 0 as we look at the ratio of successive terms. And so we want to exclude x being equal to 0. So what is the limit as n goes to infinity of an plus 1 over a sub n? Absolute value, of course. I'm going to do, again, a sub n plus 1. And I'm going to multiply by 1 over a sub n, the reciprocal. So if I replace n with n plus 1, this right here, of course, is the a sub n. If I plug in n plus 1, I get this, and the reciprocal of that is this. And I can do some simplifying, right? Remember, 5 to the n plus 1 is 5 to the n times 5, and so I can be left with a 5 in the denominator. And similarly, I can be left with an x in the numerator. Now, be careful, the absolute value has to stay around the x because, again, x could be a negative number. The absolute value of 5 is 5, so we're good with that. But again, I'm taking the limit as n goes to infinity. X is not a function of n. It's really a constant with respect to n, and 5 is a constant with respect to n, obviously. And so I can just factor that out, and I'm left with 1. And what's the limit as n goes to infinity of 1? It's just 1. And so this limit is the absolute value of x over 5. Now, if you remember the ratio test, what has to be true for the series to be convergent? Well, it's absolutely convergent if what? This limit is less than 1. Right? That's what we want, less than 1. Well, if that's true, then the absolute value of x is less than 5, meaning, of course, 5 is between negative, or x is between -5 and 5. And therefore, remember, we're centered about 0, basically, right? 0's in the middle. We're going out to 5, -5. We're talking about all values in this interval here between -5 and 5. And so our radius of convergence, right? This radius is 5. They don't ask you to find the interval of convergence, but I just wanted to look at that real quick. So this is not part of the problem. You would stop right here. But what is the interval of convergence? Well, in that case, we need to check these endpoints. Do we converge at -5 or 5? And it turns out we do not converge at either. If I plug in -5 and simplify, I get -1 to the n, which this series will diverge. It's either, you can note that it's a geometric series with r equal -1. Remember, geometric series only converge if the absolute value of r is less than 1. Or you can use the nth term test because the limit as n goes to infinity of this a sub n does not exist. Similarly, for x equal 5, we get just 1. And of course, that series clearly diverges 1 plus 1 plus 1 plus 1. And so we would not include either endpoint. And so your interval convergence would be written this way. Okay, so that's not in the problem, again, this bottom part, but the radius of convergence is.